What's the likelihood that you find exactly one person in 3 tries? So there are a couple ways that this could happen. You want exactly one, right? So you could have, in this case, you could have a no, no, yes. You could have a no, yes, no. And you could have a yes, no, no. Those are the 3 ways that you could find a type O person. The first way would be a 0.55, 0.55, 0.45 way. The second way would be a 0.55, 0.45, 0.55 way. And the last way would be a 0.45, 0.55, 0.55 way. And since there are 3 different ways to figure that out, you have to total them. So you add them all up to find your final answer. And if you total them all up to find your final answer, you find out it's a 0.0 or 0.408 likelihood that that's going to happen. Or in other words, almost a 41% chance. In this next spinner game, this is kind of like that Winter Carnival game or any other usually small event kind of game. This one's at Meadowbrook, and Renee's trying to get Leroy to play a game that she invented. He's going to spin the spinner, and then he gets a gift certificate with the indicated amount, and it costs $5 to play. And so what we want to know is what's the expected value? That's part A. So remember, you take the dollars, which is the expected value for each spot, times its probability. So for example, in the first part here, we would have $6 times a 25% chance of winning, and $7 times a 25% chance of winning, and $5 times a 25% chance of winning, and $0 times a 25% chance of winning. And what we get in the end is how much you would expect to win on average. And you find out it's $4.50. Now, if Leroy plays this game 100 times, how much money comes out? Well, you take that $4.50 and you multiply by 100 spins. So it seems like a great deal, right? Because all of a sudden, he's won $450. But in order to play this game, Leroy has spent $5 times the 100 times he's played, which is a total of $500 he's spent to play this game. Is Leroy a winner? No, he's a loser. Because he doesn't understand about expected value and fair price. Over time, he loses his money. So no, in the last one, no, the fair price is $4.50. So he should not play this game because over time, he loses. And this is what I was talking about earlier with the casinos, even paying out 90%. This one's actually the same, paying out 90%. So this last part of this question is design spinners that would make $5 a fair price. Well, we did a little bit of this earlier, so we can make a spinner that looked like this. The $20, 0, 0, 0. That's where $5 is a fair price. We could be ridiculous, and we could put $5 in each one. We could put 10 in 2 of them. I suppose we could put a 10 in 1, 2 5s and a 0, and there are more, of course, but these are just 4 examples. And you'll notice that the total in each one of the circles is $20. Because if you split that 4 ways, on average you would expect to get $5. Okay, so this is a very common kind of problem. Number 4, how many people in here have ever played a raffle? You win a TV, or I've actually played raffles. If you go in like the Raspberry Festival or Main Street Days, I can't remember which one, you can win a car in downtown Hopkins. It costs like $20 a ticket, and you can win a car. Like, that's unbelievable. So I play that one even though it's kind of dumb. All right. I mean, somebody's got to win, so maybe one of these days. A school raffle has the following prizes: a microwave that's worth $400, and the chance of winning is 1 in 2,000. So I'm just going to mark that up right now. So microwave, $400, 1 in 2,000. There's also the video game that's worth $100, and the chance is 3 out of 500. There's the bike that's worth 175, and its chance is 1 in 1,000. And we are told that 2,000 tickets are sold. And so we want to know what the fair price is for playing this game. So remember, we always take the payout times its likelihood. So in the blue, we have the payout, which is $400, times the likelihood, which is a 1 in 2,000 chance. For the video game, the payout is $100, because that's how much it's worth, and the chance is 3 out of 500. And the bicycle is worth $175, so that's the X in our formula from before, and the chances are 1 out of 1,000 for winning that. And if we put all these together, we find out our expected value, which we also sometimes call the fair price, and you find out that it's 0.975, or in other words, 97.5 cents is what they should be charging for this game. And you notice in Part B that they talk about the tickets are $2 a piece. So on every single ticket, they're going to make $2, right? And they're going to lose 97.5 cents. Or in other words, they're making $1 and 2.5 cents per ticket. How many tickets did they sell? 2,000. It said in the yellow that they sold 2,000 tickets. So I multiply this by the 2,000 tickets that they sold, and this is how much money they're going to make on their raffle. $2,050. So in the last part, when you're trying to figure out the likelihood that you win nothing, the best way to do this that I could tell you is look at all of your chances of winning and then subtract that from 1, because remember, 1 represents 100% of the probabilities. So what I'm going to do is I'm going to add up all of the different pieces first. So in this case, that means our first probability was 1 out of 2,000. I'm going to add that to 3 out of 500. And I'm going to add that to 1 out of 1,000. And this is going to give me a decimal. And this is actually my likelihood of winning. When I do this, I get 0.0075. This is less than a 1% chance of winning. That's very small. So if I want to know the likelihood that I'm actually going to win, what I do is I subtract that from 1. So I go 1 minus 0.0075, and that's 0.9925, or in other words, there is a 99.25% chance you're not going to win. Do you want to play this raffle? Not really. Not a good deal.